welcome to the Spatial Structures Movers and Shakers interview series, hosted by the University of Surrey's Spatial Structures Research Centre. Today, I'm joined by Hanaa Dahy, who is an Associate Professor of Sustainable Design within Technology and Innovation at Aalborg University. As part of Hanna's professorship, Hanna founded and led the BioMat Department Biomaterials and Material Cycles in Architecture at the University of Stuttgart. Hanna then went on to found and manage her BioMat at Copenhagen Research Centre at Aalborg University in 2022, as well as her newly initiated technology transfer company, also initiated in the same year. Hanna has received a number of industrial research grants and is a member of several European and international scientific professional associations. Hanna, thanks very much for taking the time to join us today.
Thanks, Mark, for the invitation. Thanks for taking me.
No problem at all. It's a real pleasure to have you on our Movers and Shakers interview series and get the chance to speak to you. We begin by asking guests about the spatial structures community in the area you live, which I understand is Stuttgart. So would you be able to give us a bit of an overview of that?
Well, yeah, as a location in Central Europe, I think that Stuttgart is known for different kinds of spatial structures, and especially from Otto and Schleich and many dear godfathers in that area, experimenting different approaches and inspiring all over the world architects and engineers of different kinds. So definitely it had an influence on us in that context.
Absolutely, yeah. Those are names and familiar figures which we've heard a lot about on the Movers and Shakers interview series. It's always good to hear them described as the godfathers. That's an excellent description. We also ask guests to give us an overview of their career journey to date. So maybe you could give us a little bit more background about you.
Yeah, very well. So I come originally from Cairo, Egypt, where I studied something called architectural engineering, which means that we had a kind of mixed studies between architecture and engineering of all kinds, which helped a lot further when I moved to Stuttgart later. So there I opened up a small office with my mom. She's also a professor of architecture, and then moved to Stuttgart in 2009, where I made my PhD studies, especially about biocomposites and lightweight structures, their applications in architecture. And then afterwards, I had the honor and the chance to receive the first professorship in the University of Stuttgart 2016, where I initiated the first BioMat department there, and then lately got a professorship at the University of Aalborg in Copenhagen, where there I also initiated another department of BioMat, which is for bio-based materials and material cycles in architecture. So that's basically the journey, and in between, I'm trying to match this with the real market application. So that's why the BioMat TGU at TGI GmbH in the region of Stuttgart has been initiated as well.
Excellent. Thank you very much for that, Hanna. And it sounds like a really interesting range of projects you're involved in. We're also asking guests, and I appreciate you've slightly touched on this, but about a research paper or project you are currently or have very recently been working on.
There are lots of projects, but let's say the current coming one has to do with 3D printing and digital fabrication technologies in the form of additive manufacturing technologies in specific. Also, there is one that has to do with another fabrication system called tailor fiber placement. So we are both investigating on two current ongoing projects working in parallel on ways of how to add on materials and to exactly divide them functionally according to their density and according to their capabilities of holding on forces or getting forces to move from one point to the other for load-bearing structure systems. That's what we're working on at the moment.
Amazing. Thanks very much for sharing that. That sounds absolutely fascinating. Well, Hanna, we're now going to move on to the middle section of our presentation, which is entitled Your Space, Your Structure. So I will hand over the presentation rights to Hanna, who will be presenting on a topic relating to spatial structures of her choosing. So without further ado, over to you, Hanna.
Okay, so I would like to talk a bit about the approach in BioMat about how we take materials as a design approach, as a design tool. And I would like to take you through this short journey, how we do it in the area of spatial structures. It has all basically to do with the impact of the construction industry, as we see, on the environment. It is one of the highest, if not the highest ever industry that has a negative impact on the environment, of having more than 60% of global resources consumption and more than 50% of global waste production, more than 35% of global energy consumption and carbon dioxide emissions. If we see the highest factor that has been the one thing behind our, like, say, bad reputation, if we can say, because of its impact in the environment, then this was one of the main ideas, or one of the main reasons why we went into that concept of having the resources as a start in our architectural process, in our design process, building process, if you want to say. And that's why we were able to get this as a starting point in our design process. So as you see, this is the design philosophy that I just called materials as a design tool, which is basically made of, or conceptualized around, having three major factors of design, fabrication, and materials, where we start by a material or a resource in a so-called bottom-up approach, where we see what kind of materials we have available and then understand further its properties, what kind of fabrication technologies available, and till we reach to a building component and then the whole building. And that was the main context behind the proposal of the BioMat as a unit or a department in the University of Stuttgart first, and then Copenhagen, and then even the company later. But if we look in deep how the innovation is being done in that context, this comes because we started to, or I personally started to approach colleagues from the automotive and aircraft industries, and trying to have a contact and understanding more the technologies that they have in those fields, and imagine why we don't have such developments in the same speed in our industry. And through the knowledge that has been gathered from the colleagues, and also from colleagues in the area of textile manufacturing technologies and additive manufacturing, automation technologies, generally speaking, there was a bit of input in the context of building construction innovation. Understanding the importance of the integration of modularity, designing for disassembly, caring about the whole circularity of the building construction, that was one of the aims of integrating also modularity and means of maintenance, means of designing for disassembling in our building constructions. That was one of our major targets as well. And definitely, as said, that the industrial processes or fabrication processes have been playing here like a hero role in developing further solutions for our building industry, and seeing how could architects understand how extrusion works, protrusion, 3D printing, and all of those technologies, tailoring, tailor fabric placement, thermoforming, and other additive manufacturing technologies, as well as other techniques. How can this be rapidly prototyped in the area of the offsite of the building construction, and how this could help initiating different topologies and elements in our field, and from it build different kinds of construction systems, including spatial structures. One of the major things that has been taken into account, and especially during my PhD time, I took this as like a role or a kind of mission to try to see different types of bio-based materials that are even annually renewable, so specifically fibers and natural fibers, and see how far we can go in the building industry using those kinds of materials. And what you see here basically is like a wide range of application possibilities that we have developed in BioMat so far, different types of spatial structures and shell constructions, as you see, but also being a part of a large industrial research project that is named SCB, Sustainable Circular Bridges. That was between all the projects between 2018 and today. In this presentation specifically, I would like to focus on two spatial structures. One is on by the in the area of extrusion, and another one in the area of pultrusion, that are two different types of fabrication technologies, just to showcase how this occurred in our work. But let me get you like a flashback, what actually got me into that field at all. Those are 4 different photos from 4 different continents that presents the open burnout of straw fibers, which are the agricultural residues coming out of the agricultural sector. And the farmers are openly burning that in outspace to free the land from the straw after having the cereal harvesting and the cereal production. As you know, there is some kind of the food stock that is present all over the world, if it's rice, wheat, and so on. And then the rest over of this industry, we have straw left behind, and in all over the world, in many parts of the world, unfortunately, unofficially, this kind of resource is being burned, despite that this resource is having the same inner composition like timber or wood, which again, for us in the area of the building construction field, it means a lot. It could replace timber in many areas, and that was the main target and scope. So as an architect, I went into the other part of the world, this idea of how to take this resource and take it into another level of producing fiber boards out of it in collaboration with other disciplines like the colleagues from the plastic manufacturing industry, understanding more how this could lead to different kinds of designs and applications, and that took place. And the result was this development SoC that was patented worldwide and had a market name, which was named BioFlexi. And that's the lab scale, as you see, the extrusion process that was done within the plastic manufacturing industry. And the outcome was given further into another level of applications, first on a small scale, like different kinds of furniture designs, as you see, and then even covering a wide variation of indoor applications and investigating on different fabrication systems, how this could be applied. But then another level was taken, which was how the same material could be integrated in a different approach to create a full construction system out of it, which was investigated in the BioMat Pavilion of 2018. So at that time, we had 2 different variations of biocomposite materials. And the hero, one of the heroes here was the fact that we developed, or we integrated a surface on both sides of the fiberboard, having reinforcement directions and reinforcement media, and reliant on the reinforcement direction, the integrated loading capacity was supported. And the outcome was in the form of sandwich panels that you see of different curvatures, and we were able to build all those components, or provide all those components that were around 370 pieces through only 4 molds that you see here in the back. And they were all numbered in order to put them in exact positions. And the result was this shell construction that had a span of 10 meters and a height of 3.5 till 4 meters. But then I'll get you again in a flashback of this storyline, and this took place after the pre-development of the BioFlexi and giving the students the chance to have a look at the material itself and how to make this approach doable, like the learning by doing from one side, and from the other side materials as a start in the design process. And within the investigation, both practically, experimentally, but also on the design level, the parametric design, we were able to investigate on all possible approaches, small scale, large scale, and how to make the upscaling process happening. So you see here an investigation, or one of the investigations of the process of vacuuming the panels so that we could make a closure with the veneer system. And here you can see that we tried different possibilities of connections, because this is at the end a segmented shell construction, and of course the connection elements play a very big role. And then after so many testings, we have chosen the correct variation for that system. And then we did all the progress of the whole scale, let's say, from the building element level to the pre-connection of the elements, then to putting all the elements on site. But this was not, of course, without the support of structural engineers, and this was through international collaboration at that time with the Technical Institute, with the Technical University of Eindhoven. And accordingly, there was like a scenario or construction hierarchy done on how the whole construction element that you can see, the whole shell was in the form of a curved trio, like a triangle, on two different levels of a distance between them of around the difference in the heights of the foundation, 2 up and 1 below, or by 1.5 meters. And we had to divide the very large triangle into 4 and then take the ones on the edges first, connect them or pre-connect the pieces on the ground, and then put them in the correct position. But in order to get to a high level of accuracy, we had to further cooperate with colleagues that can provide us with 3D laser scanning of the whole building site and investigate in almost real time how far we are accurate while putting the pieces in place, and also accurately putting the anchor points or the foundation points in the correct exact position. We had in this project different obstacles, like having a limitation in not being allowed to make any anchoring on the ground. We had to put certain loads inside each of the 3 footages that is no more than half a ton, 500 kilogram per meter squared, because this was the maximum allowance of the support of the loading at that area, because we had an auditorium underneath the building site. But here in this exact slide, it just shows how important is the integration of other disciplines, like the geodesy colleagues of Professor Schwieger and his team, because it was essential to also investigate on the ways of how we construct using this alternative building systems using the biocomposites. And then you see the outcome of that level of accuracy and how with each single point there was a lot to reach through all of those collaborations and multidisciplinary integration. You here see through that short video what was actually the process of doing it. So it was a bottom-up approach. We had to start from the building material itself that was very freshly developed, and this was given further to students. They had different design variations, a kind of competition. Then one was chosen, and through cooperation with structural engineers, it was possible to see the highest deformation and create more than one unit of connection. Then through testing, it was possible to see how the veneer and veneering and the veneer directions and the reinforcement could create a level of structural performance to each single unit. And then we had in our studio, or turned it into a kind of a smaller fabrication company, where we produced those 370 elements and then impregnated, connected, and coated the pieces. And then we had to have a kind of collection on site, and then we mounted each one of the triangles in place. So that's like the all-over short storyline of this pavilion. The other one that I would love to share with you is the second one that is done from another kind of fabrication system through pultrusion. And the pultrusion was done in using a totally different natural fiber, which is the flax fibers. And some of the pultruded profiles were also investigated from hemp fibers. Here is basically how pultrusion looks like. That's a fabrication system that works on aligning the fibers in a certain longitudinal direction, and the outcome is in the form of linear elements, like cylinders. And this reminds us a bit of Shigaru-ben, for instance, and having his paper tubes, which basically lies in almost the same geometrical form. And he has investigated a lot in the area of spatial structure systems, and that, of course, had an effect on our thoughts and how we take this unit of the pultruded natural fibers into another level of spatial structures. Also, definitely applying systems like active bending structures, using the bridges, and having these kinds of inputs from all those godfathers like Fry Otto or Shigeru Ben, and having almost the same interior as you see with this integrated grid structures that have active bendingness in them. Those all affected our or influenced us as seeing the other colleague pioneers in that field. So back again to the pultruded system, that is what we worked on in defining a certain hypothesis of this linear element and seeing its level of bending. And this also reminded us of different kinds of local architectural systems, as you see in different parts of the world. This is from Iraq and other Asian and Arab regions where basically different kinds of plants that had been growing there were seen as a local element. So this is like reviving the local architecture and vernacular systems back into our digital world using different fabrication technologies. And so throughout that, there were so many studies of understanding how far the curvature could go for the protruded profiles, and investigations had been done through one of the PhD candidates. And the overall system was seen as having two grids, that we have one upper, one lower, and that there would be three boundaries like beams on three edges of the whole structure system. And then on top comes the skin, which is in the form of membrane. So basically we had three connection types, something that use lashing or a kind of connection that is well known for bamboo structure systems, and then connections between the inner grid and the external contour, which was a double profile, as you see, and then a third connection system in this kind of rope that was between the membrane and the external contour. And in this project, so many investigations took place on what would be the best connection method and what would have a level of freedom, but at the same time provide the needed equilibrium. And of course, we had to look also in the different kinds of local construction systems and how the connections and lashing systems have been taking place. The connection in the bamboo world was one of the things that influenced us, and also the previous work of Shigeru Ben in that field. So this is back again our protruded profiles, and we had to go into again, just like the other pavilion, into a numbering system so that we would know the upper one, the lower network, and the connection points, and so on. And definitely also on site, we had again to have our contacts to the colleagues of geodesy and exactly provide the correct pointings of the footages, locate the foundation points. And you see here, it was essential that we minimize the number of temporary posts to locate the boundary lines first, and then to interconnect the longitudinal members till we reach the final state of equilibrium, as you see. And this is how the connections looked like at the beginning here during the construction procedure, and then finally in its final format, and then covering it with the membrane. So we had a nice chance to have many, to win many prizes, which is of course a big honor, but of course thanks to the bigger team, which was from different spectrums and sectors in the building industry, but also the textile manufacturing technologies, and different colleagues from the structural area, from the Institute of ETKI and the geodesy support and the membrane support. The very final thing that I just like to show, not necessarily in the spatial structures, but it gives an input to what biocomposites can be applied in, which is even in the bridges or slabs, and this gets us to a spectrum that biocomposites could be applied in multi-story buildings using the slabs themselves made of biocomposites, similar to the concept of having these bridges. This is one of 3 bridges that has been built. This is already built, but the 2 others are still to come in a large project named Smart Circular Bridge. And the Smart Circular Bridge is an Interreg EU project that should end next year. And it is a connection and a kind of cooperation between 4 European countries, including Netherlands, Germany, Belgium, and France. And we are generally 15 partners. I present the architectural partner for the 3 bridges that would be built in this project. And the other partners represent 7 companies, 4 further universities, and 3 cities. And the 3 cities are the cities in which these biocomposite smart circular bridges are to be built. As said, one is already built inside the garden show of Netherlands in Almere. It's a Floriade Expo. And the coming ones, one in Ulm and another one in Bergen op Zoom. This is our work or like preliminary design. And of course, inputs were from structural engineers of the project and also from the fabricator of the balustrade of the bridge. And here it looks, I mean, you can see it in its final form. The span was 15 meters and the width was 3 meters. And here during the installation. So you see that the body of the bridge itself is just foam that is wrapped all around with flax fibers. And the surface or the inside of the surface of the body of the bridge, it has integrated sensors for structural health monitoring. And one can see it in real time on an online dashboard that has this dashboard.smartcircularbridge.eu. The coming bridge, as said, it will be in Ulm, next to the cathedral, the very known famous one of Ulm. And the design is almost finished. I just finished the design, and this is how it should look like. Yeah, very soon, hopefully we will be able to make the opening. I come through this to the end of the presentation. Thanks a lot for listening.
Hanna, thanks very much for taking us through your presentation there, which covered a very interesting range of topics, everything from your bioflexing materials to the work you've been doing with BioMat. Really fascinating topics. Thank you very much for taking us through it. We usually conclude our interviews with an end section around sustainability, but that was very much the crux of your presentation. I wondered, you're obviously an excellent example of a bridge between someone who works with industry and someone who works in academia. I was wondering, with a view to sustainability, how do you think industry and academia can work together more effectively?
Well, that's our daily business, let's say. We're trying here to combine the knowledge with what is allowed to be built through norms and applying the regulations in the correct good form, and showcasing that the bio-based materials that are coming from annual renewable resources and just plants could be really turned into a very strong element and be helping our building industry to be more green and more sustainable. So it is very well known that the spread of diseases, as we saw, the corona and so on, and of course, because unfortunately of the war and the increase of prices of energy, as well as the earlier burning out of forests in Australia and in South America. All of those are factors that increase the prices and resources and decrease the resources then dramatically. And this is seen very obvious in the market and by industrial people. And so they are keen really of reaching to us and trying as good as possible to apply those approaches, because not only that it's environmentally friendly, it is very cost competitive to the existing solutions. So we're trying to prove this, and we have proved a lot already.
Thank you very much, Hanna. It's been an absolute pleasure to speak to you today and to learn more about your fascinating work. To our guests watching this interview, and indeed all the videos in the Movers and Shakers interview series, if you've enjoyed the video, Please do remember to like, share and comment. All of your views and thoughts are very welcome. And do follow Spatial Structures on LinkedIn, Facebook, Instagram, Twitter and Bilibili. Details of our social channels can be found in the description section below. Well, that just leaves me to thank Hanna once again for joining us today and for giving us a wonderful overview of her work. And hopefully we'll get the opportunity to speak to you again on the Movers and Shakers interview series, Hanna. But for now, thank you very much.
Thanks a lot for having me.